There we go. So essentially, I'm going to rewrite this as the sine of 5 over n over 5 over n. So I'm using an algebra trick. If you have n over 5, it's the same thing as 1 over 5 over n. So that's the trick. So now I can use L'Hopital. Which means that what you do is you differentiate the top and the bottom. Now, if you differentiate the sine of 5 over n, like 5 over x, you will get the cosine of 5 over n times the derivative of 5 over n, and you're just going to have to trust me, it's that guy. And on the bottom, you're going to find the derivative of 5 over n, which is also that guy. So what I can now do is just cancel those out because they're the same thing. And that means that our limit is the same thing as this limit. Now I can do brute force. I can make n infinite. Well, 5 over infinity is 0, so it's the cosine of 0, and the cosine of 0 is 1. So that's essentially how that quiz. That's how it works. Now, I'm not sure what their video did.
That makes a lot more sense. The video didn't really explain it.
Yeah, I can understand that.
But yeah, I got like halfway there. I got it to the cosine part.
Right. You can hang in here for a minute, mate. Arwen's having issues coming in, and I'm having issues getting all my windows. I've got little windows open all over the place now, and that's making my life a misery because I can't figure out where things go. Where's this thing go? I'll stick over here. Okay, here's Javon coming in. Here's Sean coming in. We're almost all here. And what's the time like? We should be getting started at any moment. Well, good morning, everybody. If any of you have any other homework questions, we'll do those guys at the end. You can just hang about and ask. And if you just want to hang about at the end and watch someone else's questions, feel free to do so. Got one last minute person coming in. I'm going to mute you all. I'm getting some kind of feedback. So when you want to ask anything or answer any question, you just hit the spacebar. Well, as I was saying, good morning. Let's jump right into section 11.2. Here we go. And it's intro to series, and we already looked at geometric series, and we're going to do some more of those because that's the major chunk of the questions in section 11.2. I'm then going to move on and do a little bit of examples of other series. We're going to look at a harmonic series, which we have touched on. And then I'm going to tell you about a telescoping series and a new test, another test called the divergence test, which basically allows us to tell if a particular series converges or not. Now, the first kind is back to geometric, so this is kind of an overlap from yesterday. A geometric series, which I'm going to call GS from now on because it saves me writing a lot. Now, according to the theory, the geometric series test, if you have a geometric series and you find R, which is called its common ratio, if the absolute value of that guy is less than 1, then the series will converge. And if the absolute value of it is greater than or equal to 1, then the series diverges. If it does converge, then the sum of that series, what all the terms added together would give you, is found by a very simple formula of A over 1 minus R, where A is the original first number in the series, and R is the common ratio. Now, you can be given geometric series questions in a number of ways, so I'm going to try and cover each one of them again. First way is they'll tell you it's a geometric series, so you don't need to worry about is it one. They'll tell you the geometric series, and then off they go. So here is a geometric series. And the typical question is, does this series converge? And if it does converge, what's its sum, right? That's a typical question. I need to know just two things. I need to know A, which is easy. It's the first number, right? Then I need to know the common ratio. If you have problems finding the common ratio, because sometimes it's hard to do in your head. If we call this guy A1 and we call this guy A2, if you take the second term and you divide it by the first term, right? If you take the second term and divide it by the first term, in this case, -8/3 divided by 4. That gets you eventually, you're going to have to trust me on this, but that eventually simplifies down to -2/3. Can you trust me on that? Or you could do it in your calculator or whatever, but that's what it becomes. That's how you tell what the common ratio is. You just take the second term and divide it by the first and simplify it down to a nice fraction. Now, in this particular question, would you agree that the absolute value of this is less than 1, so it converges? So that's that bit done. And since I know that the absolute value, which in this case is 2/3, is less than 1, the series converges. I can then find its sum. It's A over 1 take away R. That's where the A comes in now. It's 4 over 1 take away -2/3, which is 4 over 1 add 2/3, which is 4 over 5/3. Can you just trust me, but that's 12/5. So if you imagine continuing with this pattern to eternity, essentially the limit of this series, right, would be 12/5. It wouldn't quite theoretically be 12/5. It's a limit thing, right? It gets infinitely close to it, right? You'll get closer, like the poor little frog jumping, right? You don't quite make it to 2, but for all intents and purposes, it's still 2, right? It's a limit thing, which is what freaked the Greeks out because they couldn't. That concept of limit was not in their vocabulary, so they didn't even think in that way. Are we cool then that if you're given a question where it's a list of numbers like this, that you can find the A and the R and then answer the two basic questions? Does it converge? And if it does, what's its sum? Okay, it's the first kind. Second version of that same question, you'll get a guy that might look something like this. Now, when a geometric series is written in sigma notation, they very often look like this, kind of clunky looking, right? Now, I need to know two things. One of them is actually very easy to get. Isn't the common ratio value R whatever is here? In this case, 5/7. Now, if this said 5/7 to the k minus 1, 5/7 to the k plus 1, right? Something like that. It's still 5/7, right? So they're going to be a bit that looks something like this. You know, some fraction to the power of k, k plus 1, whatever the letter they want to use, right? That fraction is your common ratio. Can you remember from yesterday, how do I find the value of the first number, A?
Place K with 1.
In this case, 3 times 5/7 to the power of 1, which gets us a rather ugly 15/7. Would you agree this converges again? The absolute value of R is 5/7, which is less than 1, so it converges. And that means then it has a sum. And the sum is that guy. And A is this fella, and R is this fella. So it's 15/7 over 2/7. And again, you're going to trust me, it ends up being 15/2. For completeness sake, here is a different geometric series written in sigma notation. What is the R value for this fella? What's the R value? Right. Would you agree that the absolute value of 4/3 is bigger than 1, so this series diverges? For homework questions, the ones that diverge are very easy, because isn't that the end of the question? It doesn't make sense, what does it add up to? Because it doesn't add up to any number, right? It's just undefined or infinite, depending on the situation. Are we cool? Oh. Let's get you thinking. They're telling me this is a geometric series, even if it doesn't look like it. Secondly, it's written down in its sigma notation, but it's not written in this standard form here, which makes it a little bit harder to suck out the two numbers that we need. Don't we need A and I? That's the two numbers we need. If you tell me just those two numbers, I don't even need to know that anymore, do I? Everything that I need is contained inside knowing who A is and knowing who the common ratio R is. Now, to get A, won't you just plug K equals 1 in, which ends up being that. So far, so good. Now, how am I going to get the R? Well, I'm going to do something we haven't done in another question. I'm going to plug K equals 2 in here, because that's going to tell me who the second term is. And although I don't need to, I'm going to plug in K equals 3, K equals 4, blah, 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 blah. Now, if I write it down as a list of things being added, can't we use the technique that we used over here to find the R value? Great. Now, how do you get the R, the common ratio? Then don't you take the second guy and divide it by the first guy. Second term divided by the first term. Second term divided by the first. Oh God, this is too hard to do in my head. Okay, so it's that guy divided by that guy. So it's that guy times that guy. Cancel, 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 cancel. Oh, it's 1 over pi. And so the common ratio is 1 over pi. By the way, isn't pi just a number? It's nothing special. It's just a number that happens to have a letter associated with it. Is the absolute value of 1 over pi, which is that less than 1? Yeah, isn't pi 3.14 and some other stuff? So 1 over 3 point whatever is definitely less than 1. So that makes it converge. And what does it converge to? Well, I know A and I know R. So its sum is A over 1 take away R. It's 4 over pi over 1 take away 1 over pi. I'm going to write that again. Style points. We are not going to let that poor fraction stay like that, right? It's not going to go to a party dressed like that, right? We have to make this guy look better. I'm going to do a little trick. Can't you just multiply it by 1? But the special version of 1 I'm going to use is pi. And what that's going to do is 4 over pi times pi gets me 4. 1 times pi gets me pi. And that. Would you agree that 4 over pi minus 1 is just much prettier looking? And so that's just a little bit of algebra to make it look good at the end. Oh, poor Matthew's been waiting for a while. There we go. So far, so good. So if I give you a geometric series written like this, or if I give you a geometric series in sigma notation that looks like this, or if I give you a geometric series that just looks weird like this, you feel comfortable about how you're going to find the A and the R so that you can tell if it converges, and for the ones that do converge, what the sum is. You feel good? Okay, then let's move on to the second topic on my list, which is quite a short topic because there's not really that many examples of it. And this is harmonic series. I'm going to change the letter of the alphabet, and I'm going to use I because I want it. That is the harmonic series. It's 1 plus a half plus a third plus a quarter for eternity. You could also use K. And you could also use, I don't know, N. Mathematically, the variable I, K, and N don't really matter. Aren't they exactly the same piece of information? Right? So don't get caught up by whichever letter of the alphabet, you know, the question happens to decide to use with sigma. I think they're inconsistent. Let's have a look. Oh, they like N a lot. Okay. Oh, and they like K a lot. Okay, so they at least use 2, if not, you know, 3 of these, right? So, and there's no significance to the letter that's being used. But these guys are called harmonic series. And now you're just going to have to trust me. They diverge. Right? They do, right? They add up to infinity, right? They diverge. So if someone gives you a sequence and it's a member of the harmonic series, that just means it's like the harmonics. It's a multiple of it, right? It's twice the thing or half the thing. It will also diverge for the same reason. So if I gave you, for instance, 1/2 plus 1/4 plus 1/8, oh no, plus 1/6, sorry, plus 1/8, there we go, plus 1/10, forever. And you were trying to find out, does this guy converge or not? What you have to realize is that if you take out a common factor of 1/2, isn't this a half of a harmonic series? And isn't half of infinity still infinite? So it diverges. So anything that's related to a harmonic series, right? It's in the family of these guys, like this one here, will diverge. And now there isn't that many of them, right? There's not that many questions that use the harmonic series. So and they won't tell you it's a harmonic series. They will just say, does this series converge or diverge? Do you recognize that guy is in the family of the harmonic series? What fractional common factor could I suck out of this to make it a little bit more obvious?
1/3.
I hear you, and I agree with you. So it diverges. Can you imagine there's not that many questions that you can do to harmonic? Right? There's only so many ways. Here's another one that might catch you. Hopefully it won't. What fraction do I pull out of this one?
Four and 1/3. 4/3.
Yes. You see the little darlings? See the little sneaky guys hiding? I could have made this one even sneakier. This is the same one as this. Do you see what I did to be sneaky? When it's written in this format, it's a little bit easier to see it's a harmonic, isn't it? But when you take some of these fractions and you simplify them down, do you see that now it becomes less obvious that it's a member of the harmonic series family? So if you have a set of fractions like this, and they don't seem to have a nice flow to them, will you look at maybe changing them in some way? Because they're probably going to be a disguised harmonic. Any questions? Are we good? Are we good? Move on. Okay. And that takes care of harmonic. Let's look at the third one on my list. It's called the divergence test. Okay. Imagine that you have a series. And I'm going to write it like that. So can you imagine you just take any series at all, right? A1, that would be equivalent of saying A1 plus A2 plus A3, right? It's like taking a sequence, AN, and adding them all up, right? Suppose I had a series that looked like this. The divergence test says the following. If the limit as n tends to infinity of the individual terms an, if the equals L, where L is greater than 0, So any number that's not 0, then the series diverges. On the other hand, if the limit of n tends to infinity is 0, it's inconclusive. All that means is we don't know if the series converges or not. You can't use this test to decide that. Let me show you what that would look like. Look at that series. Now, I don't typically write these things down in their usual long form, but if you plug in 1, you get 2/5. If you plug in 2, you get 5, that's meant to say square there, 4, 8, 5/11, and then you plug in the next one and the next one and so on. So I guess the question is, how do I tell if that series converges or not using the divergence test? Well, all we do is we find the limit as n tends to infinity of the individual pieces that make up the series, right? They're all made up of lots and lots of those guys. I can solve this question in the usual Calc 1 way. Can't we do L'Hopital or divide top and bottom by n squared? Which method do you want me to show you? Because both work. Do you want to see L'Hopital or divide top and bottom by n squared? L'Hopital is it? Okay.
L'Hopital.
So you put a little L, so yeah. So a little L to tell people we're doing L'Hopital. Basically, L'Hopital, you differentiate the top and you differentiate the bottom. Oh, wait a minute, can't you cancel and get a half? So the limit is 1/2. And so by the divergence test, the series diverges. So if the individual pieces have a limit that's bigger than 0, right? If it's a number like a half, anything that's bigger than 0, it diverges. Okay, that's called the divergence test. Let me see if I can find one to play with. Here's one. This is similar to question 9. And we're going to use the letter k because they do. And it's going to be 2k squared over, I don't know, 3k squared, 3k plus 10. And the question just says to determine whether this series is convergent or divergent. And then if it is convergent, find its sum. So let's go for the limit. I'm going to use k just to be consistent. Now I can find the limit of this by using L'Hopital. Can't I also get the limit by dividing the top and bottom by k squared? Right, since the previous one I did L'Hopital, let's do the divide top and bottom by k squared method. So what do we get now? We get the limit as k tends to infinity of 2, 3, take away 3 over k plus 10 over k squared. Now when you plug in infinity, you get 2, you get 3, you get that term, and you get that term. But these are both 0, so the answer we get is that the limit is 2/3. And according to the divergence test, if the limit is bigger than 0, right, if it's a number bigger than 0, in this case 2/3, the series diverges. Do you like the divergence test? Does it have a kind of, you just find the limit of the bits, and if it's not zero, it diverges. If it is equal to zero, you better find a different test, right? And we'll show you. Actually, I believe there's 9 tests by the time you've finished chapter 11. 9 different tests. What ones do we know right now? Geometric series test, divergence test. Right? So 7 more to go. But nonetheless, it worked here, so that's great. Any questions about that? Can we move on? Okay, move on. I'm not going to do the telescoping series yet, because now we're going to look at series that are a little bit of a Frankenstein series. And what do I mean by that? Well, the series are really not one thing, but maybe a couple of things, like Frankenstein, a leg from here and an arm from somewhere else. So here are some examples of those. Can you see that this series is essentially made up of 2 pieces? A 1 over n and a half to the n. And the questions are pretty much the same for all of them. Does it converge or not? And if it converges, what's the sum? Right? That's the kind of typical question. What you do in these questions is you split them into 2 pieces. Okay. Now, do you recognize this guy in his sigma notation? Do you recognize this guy? What's his fancy name?
Geometric.
Sounds like it's something to do. That's this one.
Oh,
It's a harmonic.
It sounds like it's something to do with mute harmonic. So this fella is harmonic. It's a harmonic series. And this one here isn't not a geometric series, right? Now let's focus on the harmonic series. Does a harmonic series converge or diverge?
It diverges.
Diverge.
Right. Which is another way of saying, doesn't it add up to infinity? Now, this geometric series may or may not converge. I don't care. Because won't this kill it? Because we're talking about the overall series, right? And the way I kind of phrase it, if one bit's broke, the whole thing's broke. So what does that tell me? It tells me that this entire series diverges. Because if this is infinite, does it really matter if that adds up to 4/3 or 2? Won't it have no effect? Infinity add 2 is still infinite, right? It's still going to be diverging, right? So break them into 2 pieces. If either one of those 2 pieces diverges, then the entire combined series also diverges. That makes sense? Yeah. By the way, that question there is similar to question 12 in the homework. I'll try to see if I can find any others. Okay. There's one of those Frankenstein series. It's got two pieces, right? The arms made out of this and the legs made out of that. When you do this one, there is the two separate series that it breaks into. Do you recognize that both of these are geometric series, even although the question didn't tell you they were? Are we comfortable, because we've seen enough of them, to recognize the shape that geometric series has, right? So a little invisible dotted line. Okay, let's go for the easy one first. For this geometric series on the left here, what is the value of R?
1/2.
So it converges, right? On the right-hand side, would you agree it's 2/3? And good news, doesn't that also converge? That means that this thing converges then, because isn't it made up of two pieces, both of which converge, therefore everything's fine. Now, I'm going to find out who A is. If you plug in 1 here, can you trust me that you get that? If you plug in 1 here, oh yeah, I wish I thought this through before I chose this one. That's going to be 4/9, 4/3. Right, I'm not going to do the rest of it, but can you imagine I find out what S is, and then I find out what S is. When I take the first answer, take away the second answer, and that's what it converges to. So, dot, dot, dot. So if you get a series that is a Frankenstein series, it's made up of a bit of typically two pieces, then will you look at that question as two separate series? And if one of them's divergent, the whole thing is broke. If both of them work, then finish them to the end and they converge, right? And then find the answer to each and subtract them in this case. I mean, if that was a plus, wouldn't we just add the two? It wouldn't really make any difference apart from that. Have we any questions? Are we good? I'm going to move on if we are then. Let's move on. Telescoping series. What on earth does a telescoping series look like? Oh, by the way, it's not one of my made-up names, because you know I called the last guy Frankenstein series. You won't see that on the internet. If you look up Frankenstein series, you'll probably get a list of movies, right? It's just, I like making up names that give me an idea of what I'm trying to convey. This is a proper name. If you look up telescoping series, you will be able to find videos on YouTube about it. You might well want to, because this is a bit messy. This is not clean. Start off by showing you an example of a telescoping series. K equals 1 to infinity. Now, you will normally be told that you're looking at a telescoping series, because in the question they will call it a telescoping series, or they'll ask you to find the sum of a telescope telescope or telescope sum or something. The word telescope will be in the question. So if you see that, you know you're dealing with it. Here is the guy that we've got. Now, what we're looking at here is essentially a log take away another log. And I know that it looks like it's, oh, you're going to separate them into two sums like you did the last time. No, I'm not. These are treated differently. In fact, they're treated in a rather strange way. What you do essentially is you write down the first 3 or 4 or 5 or 6 terms, whatever it takes, to get a general idea of how this thing's going to behave. I'll show you what I mean. If you plug in 1, you get the natural log of 1, take away the natural log of 2. If you then plug in 2, you get the next answer, which I'm going to write underneath it. And then the next answer underneath that. And then the next answer underneath that. Can you imagine this continuing to eternity? The way I'm writing it vertically is just so you can see it a little bit clearer. But technically, isn't it this guy plus this guy plus this guy plus this guy? But you're unsure of room. Do you know something really quite interesting is happening here? Do you notice things getting killed off by other things? Agreed? And I'm stopping at some random guy. I'm calling it K. Now, what do I mean by that? Won't this term be killed off by that one? Assuming you add this to this, don't the log 2's die? But wait a minute. Won't the log 3's die? Won't the log 4's die? Won't that log 5 die with a guy that would be there? In fact, won't everybody die, including that one that goes there? So what will be left at the end? A log 1 take away a log of k plus 1. Wait a minute. Doesn't k go to infinity? Right? Doesn't k go from 1 and finish at infinity? So won't this thing be the log of 1 take away the log of infinity, which means that it diverges? So for a telescoping series, you write down the first 3 or 4 terms, whatever it takes you to feel comfortable. You finish with this guy. You look at how the carnage is taking place. In this case, everybody dies except the first guy and the last guy. And then you say, what would happen if k became infinite? And in this case, the answer would be the natural log of 1 take away the natural log of infinity, which we all know is negative, infinity. It diverges. In fact, it would diverge to a very big negative number. Here's another one. I'm going to do n this time. Here is a telescoping series. Telescoping series typically are made up of 2 things subtracted. And if you plug 1 in, you get a third, take away 1. Then the next one will be a fourth, take away a half. Then it's 1/5, take away a third. 1/6, take away a quarter. 1/7, take away a fifth. And then I'll finish like that kind of random guy. Okay, let's see who gets killed. Won't that 1/3 later on get killed by that negative 1/3? Won't this 1/4 later on get killed by that negative 1/4? Doesn't this 1/5 get killed off by that negative 1/5? Do you notice that 2 numbers made it out alive? Won't those 2 survive? Now, what's going to happen towards the end? Well, can you imagine this guy gets killed off, and this guy gets killed off, and this guy gets killed off, and this guy gets killed off? what's going to happen is that you're going to be left with a guy that looks like this at the end, aren't you? In fact, you might be left with two of those. But if all of this ends up being just that, what's going to happen to this last term? Actually, there's two of them. But what's going to happen to this last term when n goes infinite? Won't it just become 0? And that means that it converges. And while you're finding out that it converges, don't you get as an added bonus what it converges to? In this case, neither 3r's. So when you do a telescoping series that converges, there may be one or sometimes two terms at the beginning that will survive. Everything in the middle will get killed, and there'll be one or two terms at the end. And if the terms at the end go to 0, as this one does, it'll converge. And if the terms at the end go infinite on you, it will diverge. And that's the gist of a telescoping series. You see, it's not as clean as the others.
How do you know that
good?
1 over n gets cancelled instead of the 1 over n plus 2?
I'm just basing it on the direction that the kill is happening. So this guy gets killed going that way.
Okay, thank you.
Not that it would really matter for this one, but wouldn't we also need to have a 1 over n plus 1?
Yes, there'd be two terms that would
Okay.
survive. But the reason I think I did mention there's two, but the reason I just worried about one of them is both of the terms that are left alive are going to be 0. So you only really need to know what one of them looks like, because you know the others are going to behave the same way. So if one of them's infinite, I don't really care if the other one's infinite, it's still going to diverge. I'm much more interested in making sure that I get the ones that survive correct. Because it's important that you know these two make it out alive, because they're going to be what it converges to. But you're quite right, there are two terms at the end. I'll do one more of this type. While I'm getting set up for that, do you want to say hi? Oh, let's stick a 10 on it. Okay, here is a telescoping series. Essentially, I'm just going to plug in n equals 1, in which case I'll get 10 quarters, take away 10 thirds. Then you plug in the next one, it's 10 fifths, take away 10 quarters, 10 sixths, take away 10 fifths, probably one more, 10 sevenths, take away 10 sixths, and 10 n plus 3s, take away 10 n plus 2s. Okay, who's going to get killed? Won't that 10 quarters get killed by that guy? So do you notice the direction of the kill is that way? Won't this one get killed by that one? Won't this one get killed by that one? Won't this one get killed by somebody over here? And won't this guy get killed by somebody up there? So in this particular question, there's only one term at the bottom and one term at the top. That's what that telescoping series simplifies down to. All the other terms get killed off by someone else. So there's one guy left alone at the top and there's one at the bottom. If you want to be really precise, as Kathy was saying, if there's two guys at the top, there's going to be two guys at the bottom, right? If there's three guys here, there's going to be three guys at the bottom. Okay. But in this case, one guy alive at the top, one guy alive at the bottom. Now, what's going to happen to this as n goes infinite? Won't this become 0? Right, 10 over n plus 3 becomes 0, which means that this thing converges, and it converges to negative 10 thirds. Are we feeling a little bit more comfortable about the telescoping series right now? If somebody didn't tell you it was telescoping, if it was written in this sigma, somebody, take away somebody, wouldn't that make you think telescoping series? Right? Its shape kind of lends itself. They all kind of look like that. At least these ones do. Now, we don't have enough time today, but when I see you tomorrow, we are going to look at some other telescoping series. They just don't look like them. And we're going to use a technique from Calc 2 called partial fractions. Can you remember partial fractions? It was essentially a technique that you used to integrate fractions, right? Things like 4 over x plus 1, x plus 2 dx. Remember those ones? Partial fractions. So if you want to brush up on that before I see you tomorrow, it'll probably make tomorrow go a lot smoother. Otherwise, when I see you tomorrow, we'll have to do a recap on the process of how do you take a single fraction and break it up into its partial fractions. And when you do break it up into its partial fractions, it's going to look like these guys. And that's how you get your telescoping series. Right? So it'll start off as a single fraction. It will turn into two partial fractions like this, one subtracted from the other, which will be a telescoping series, and then we'll use this technique to solve. Okay, we are good for today. I'm assuming everybody had said hi. If you have, that's great. And I will see you tomorrow. If you have any homework questions or whatever, just hang about to the end and we'll deal with them then. Apart from that, bye guys.
Thank you.
You're welcome. Okay, who wants to start first then? Looks like I've got some customers. Anybody got a question to start the ball rolling with?
I have a quick question about the geometric series or the telescoping series. So, and the other series that you made up the name for, like the Frankenstein series.
The Frankenstein series.
Yeah.
Yes.
Right. So
yes.
So you use the Frankenstein series when
your voice went off of mute there. Let me ask the question I think you're about to ask, or I'll maybe answer it, I should say. When the two terms are different looking from each other, then it's a Frankenstein. So you'll have like a half to the k and a n k, an n squared plus 1 over n squared minus 2, right? You'll have two distinctly different looking things. That would be a Frankenstein series. It would be done by separating them into two distinct series and dealing with each one in isolation.
Okay.
When the two terms are similar looking, like 1 over n take away 1 over n plus 2, right? 5 over n squared take away 5 over n squared plus 1, right? That kind of two things subtracted, but they're very similar looking. You will be looking at a telescoping series. And in many of the questions, they mention the word telescoping in the question, so it's a little bit easier to tell that you're in that world.
Is that the format?
That your question?
Yeah, it was. Yeah, thank you. And my follow-up question is that the format of the question on the test? Are you going to tell us it's a telescoping?
In the homework, depends on the question. As you'll find out, there's two distinct kinds of questions. Probably I will mention it just to make your life a little bit easier.
Okay, great.
But it's, in some questions, it's pretty obvious that it is because it's 1 over n take away 1 over n plus 1. Yeah. So if I forget, I wouldn't feel too bad because I'm assuming you would recognize it.
Yeah.
Okay, what's our next question then going to be? Anyone got a question? Jocelyn, are you here Or are you just not saying bye-bye yet? She's gone. Okay, well, assuming Jocelyn's not really here. Anybody else? Sam, have you got a question? Or are you waiting for everybody to leave to ask it? Ivan, maybe that's the same for you. Either you got a question?
I'm still forming the question that I'm asking.
Okay, you keep thinking about it. Ivan, you get anything that's concerning you right now?
Yeah, I had some trouble with number 15 on the homework.
What section is that? Is it on the section we're on right now?
11.1.
Okay, so let me go out of this and back in to 11.1. And it was question number
15.
What was the question? 15, so it's quite near the end. Let's have a look at it. Oh, okay. All right, let me show you how you would tackle that one. Now, remember, we're in sequences right now. So we're talking about finding the limit as n tends to infinity. That's basically all you do, right? Wait. So it's a different family question. So this is the guy, at least this is my version. You might get a slightly different version because WebAssign changes them around. What I would do here is combine those two logs into a single log using the rule that if you subtract two logs, it's the same as the log of the first one divided by the second. Then I'm going to use, right, what's the limit as n tends to infinity of this guy, right? And you are allowed to switch places. So the limit of a log is the same thing as the log of its limit. Right? It's a bit of algebra that you're allowed to do. Now, this fella here is actually quite easy to do. I could do L'Hopital on it and get the answer 1. I could divide the total bottom by n and get the answer 1. But I still would get the answer 1, right? Depending on which way you want to do it. And the natural log of 1 is 0. So that particular one has a limit of 0. Now, do you know if you stuck a sigma around that, wouldn't that be a telescoping series? Totally different question, totally different answer.